And what, like up to 62 or something? Sounds right. It's an awful mess you just made.
Yeah, I didn't do this. There you go, bro. Come on. Wow. You gotta pick that up. Yeah, pick it over here. Diego, pick up your mess, bro. There you go. Diego's not in the bag. That's what I'm saying.
Does anybody have homework questions? I think we're through 60, or assigned through 62. Happy to take a few minutes here and do some. Nothing for right now. That's okay. So today then, we're going to be talking about polar functions. So to do or to talk about this, what we're going to need, or our primary tool, is going to be these 4 equations from the previous section that are allowed us to convert between a polar point and a rectangular point. In this section, we're going to be mainly worried about converting between polar functions and rectangular functions and vice versa. So let's say that we have, or we're asked to convert the polar function r equals 6 cosecant theta and turn that into a rectangular equation, like a y equals, or something with just x's and y's in it, right? So if I'm looking at this, I know that seems like I'm going to want a y equals equation. So I'm going to be looking at trying to get an r sine theta somewhere in my function so that I can make that substitution and turn it into a y. Now I see that I have an r, but I don't have is a sine. However, when I look at cosecant, I remember that what? What do I remember about cosecant? It's 1 over sine. Yeah, aha. Okay. So then if I multiply both sides by sine, I now have an r times sine theta. So I can just rewrite that as y. So that is just the equation y equals 6. Y equals 6? It's just like a horizontal line, isn't it? That seems like that shouldn't be right. Let's look at our calculator. Let's see. I'm going to be in polar function. I'm graphing, so I'm going to change it back to radians. And r equals 6 cosecant. Well, I don't have a cosecant button, so I'm just going to do 6 divided by sine. And then let's hit graph. Oh. Well, that is a horizontal line. Looks like y equals 6 even if I count those little tickies. Okay, well, I guess I did that right. Well, that's a surprise. Let's try another one. Are they all going to be that easy, Mr. Kulik? Yeah. Ho, ho, ho. Yeah, no, they won't be. But some of them could be. All right. Let's take a look at this one. We have r equals 6 cosine theta. So if I go and I try to, I think back to these set of equations that I have to use, and there's not going to be really a way for me to get like r times cosine theta, right? Since I have a cosine in there. But to get it to the other side, I have to divide. So I'd have r times 1 over cosine. That's not the same. Doesn't seem like there's an obvious thing to do here, right? Well, let's look at the graph. Maybe if I know what this is supposed to look like, I can get an idea. So let's just take a minute, look at the graph. So I'm just going to graph 6 cosine theta. See what that looks like. What is that?
Circle.
Circle. Who remembers from geometry the general equation for a circle?
Isn't that x squared plus y squared?
Well, close. That's if the center is at the origin. Well, then we have to use this one that I've written, where h comma k is the center. If the center is 0, 0, then it's just x squared plus y squared equals r squared. But so that's what we need it to look like. Okay, well that helps a little bit, I suppose. So somehow I need to take this and get it to look like that, right? So I guess the first thing I would do is I say, okay, well, I'm going to need an r squared to get the x squared plus y squared part. So let's just multiply both sides by r. Because if I do that, then I can say that this is x squared plus y squared is r squared. And I noticed something else here. What else should I notice? I have an r cosine theta. That's x. Oh, this is starting to look way better. Everybody so far so good? So the whole key is just using these little formulas, right? It is kind of like a proof. All right. Well, I got to get it to look like this circle equation, right? So let's get everything onto one side. So I'll do that. Now, again, I'm trying to get it to look like that circle equation. The y squared, that's easy. I mean, I can just write that as like y minus 0 squared there, right? Whoop-de-doo-doo! No big deal there. But how am I going to get x squared minus 6 and turn that into something where it's like that? Well, no, I don't want to factor out x. If you guys think hard, back to Algebra 2, you did this last year in your Algebra 2 class. There's a procedure to take something like x squared minus 6 and write it as the quantity, as a quantity squared. Does anybody remember the name of that process? It's 3 words. That's the name, yeah. Completing the square. Very good. So the idea here, yeah, somebody remembers now. Yeah, well, that's the important part, is the how to do it. So the idea here is I want to take something like this so I can factor it just like that, right? So if I look at what I have x squared minus 6x. So the a is going to be my x, and my 2ab, well, let's just make it 2b has to be then negative 6, right? Everybody's okay with what I've done? So what's b then? Negative 3. Because I divide by 2, both sides by 2, right? Not negative 6. 2b is negative 6. Not 2b, that's a Hamlet joke, is negative 3. Ha 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 ha. So, what am I missing? What am I missing here to make it a perfect square? Negative 3 squared. Sure thing.
Why is b negative 3?
Why is b negative 3? Because 2b is negative 6.
So isn't the equation x squared minus 6x? No, the equation is a squared plus 2ab, so 6x is 2ab.
So, yeah. So I'm trying to make x squared minus 6 be the same thing as this. Oops. So I'm saying, okay, well, x squared is a squared, so x is a. 2ab is negative 6x, so 2b is just negative 6. So b has to be negative 3. So the missing piece, the piece highlighted in green there, should be negative 3 squared, b squared. So I think, as Elena was saying, we just take that middle coefficient, divide it by 2, square it, and add that to both sides. Now, I want to be clear here. As long as the leading coefficient on your squared term is 1, it's that simple. If that leading coefficient isn't 1, it gets a little bit more complicated, but I don't think that happens in this chapter, so we're just going to leave that, and we'll deal with it if it happens to pop up, but I don't think it does. Okay. So this is going to factor to just be a plus b squared, and then 0 plus negative 3 squared is 9. So there we go. We have x minus 3 squared plus, I can just write that as y squared. I don't have to write it as y minus 0 squared. And that'll do. What do you guys think? It's all right? Let's do another one. All right, same idea here. Well, let's just start by looking at the picture because that seemed to be quite helpful, right, to get an idea of what shape we're shooting for. What do we get here? Another circle. So we'll just approach this the same way then. So what's the first step going to be? Multiply both sides by r. Good. And then I notice, what is r squared? The same as x squared plus y squared. Excellent. What is r cosine theta the same as? X. And then what is 4r sine theta the same as? Y. Go back and color code some of this stuff so you can tell next time. Okay. So this just turns into another, like, completing the square problem, right? So move everything on one side. So what do we need to add to both sides to complete the square for the x's? So I'm going to take the coefficient on the x, divide it by 2, and then square it. And we'll add that to both sides. What do we need to do to complete the squares for the y? Yes. That was supposed to be a 5. Okay. Everybody feel okay with what we did there? Okay. What does this one factor to? What do the x's factor to? X, and then is it plus or minus? Plus. And then 5 over 2. And I know it's plus because that was a plus, and I know it's 5 over 2 because the thing we squared was 5 over 2, right? Okay, then we're going to have y, and is it plus or minus? Minus, and then what's the value there? 4 over 2. Or just, I'm going to write 2. So 25 over 4 is 5 over 2 squared. 4 over 2 squared is 4. And if I make a common denominator with a 4, that's really 16 over 4. So there we go. That's my rectangular equation. As an aside, what's the center for this circle? Close. Yes. And the radius? Square root of 41 over 4. Or just the square root of 41 over 2. Where the 2 is no longer under the radical, right? What do you guys think? Is this going okay? Not too bad, right? Again, I think the first section in this chapter was kind of the hardest section. Here we're going to be doing the reverse. We're given a rectangular equation and want to convert it to a polar. What am I going to use to do this? The same 4 formulas that we've had before. So I notice y is just r sine theta. A polar equation has r by itself, so I'll divide both sides by sine theta. So that's fine. Or you could write it as what else? Yeah, 4 cosecant theta, since sine theta is, or 1 over sine theta is cosecant theta. So that was really easy, right? No big deal there. What if we give you something like this? X minus 3 squared plus y plus 6 squared equals 45. What are we going to do with that? Yeah, so remember each of these can FOIL out. So what's x minus 3 squared when we FOIL that out? Good. So again, just remember we've got to make sure we FOIL that. We're not just like distributing exponents, right? Distributing exponents, very, very bad. FOILing, very good. Okay? So what did that get us? Okay. So if we subtract 9 and 36 from both sides, we can do that.
Return the x squared plus y squared into r squared.
Okay, so that gives us 0. And then, sure, x squared plus y squared is r squared.
X to r cosine theta and y to r sine theta.
Sure. Okay. Now what?
Subtract those over divide by r cosine.
Okay, so add 6r cosine theta over to the other side and then subtract 12r sine theta to the other side. And now, Nolan, you're saying divide both sides by r. So that's what we got. Now, there is one little step here that we have to be kind of careful about. What step here requires a little bit of explanation before we say this is our final answer? Nope. Which one of these steps was the potentially problematic one?
Divide by r.
Yeah! Right? When we divide by a variable, we know that that can get us into trouble here. Why is that? Because the variable could be 0. Now let's go back and think. In a polar coordinate, what is an r value? What does r represent? It's the distance of the point from the origin. So if we have something where r is always 0, what's that going to look like? Just the point 0, 0, right? It's all you can have. What is this? It's not 0, 0, is it? It's a circle, right? None of those points, in fact, are probably 0, 0. I don't know that for sure, but seems unlikely. Well, I mean, I can maybe, yeah. Seems unlikely, right? So, since that is a collection of points, not just one single point, I know it's okay to divide by r here, because if r is 0, I'm not getting the picture. The rectangular coordinates, or the rectangular function that I started with, it would not be the same. So it's okay to do that in this case. Is everybody okay there? Will it always be that way? Yeah. But I don't like getting the habit of dividing by variables without like really having a nice discussion about, is this really okay to do? Why is this okay to do here? And it is okay to do in this case. that feels like enough to me for today. So at this point, you guys can now do up to 72. That's all I have for you guys today. My suggestion for you would be to get your stuff out and start doing some work, right? You have a busy, hectic week with a lot of distractions and extracurricular things going on. Like, get some work done now and save yourself some grief later on, right? This is Mr. Kulik trying to take mercy on your soul and being helpful, right?